Principle of mathematical induction. Principle of mathematical induction. What is meant by principle of mathematical induction? It can be stated like this. If a mathematical statement is true for n equal to 1, where n is a natural number, and by assuming it as true for n equal to k, if it is possible to prove it as true for n equal to k plus 1, then we can state that the given statement is true for all positive, real, integral values of n. This is a procedural technique which we use to follow in any mathematical to prove any mathematical statement that contains n. N refers to natural number. How to quote that one? Let P of n is a mathematical statement. Mathematical statement. First step, for n equal to 1, it is verified that as true. Second point, by assuming it as true for n equal to k, k belongs to n. Third one, if P of k plus 1 is proved as true for n equal to k plus 1, then we can state that P of n is true for all positive, real, integral values of n. Integral values of n. This is called theorem of mathematical induction. Now, in any statement which is having n refers to a natural number, whether it is an inequality or equality, to prove it as true or correct, we will use 3 steps. By substituting n equal to 1 in the given statement, we will verify whether it is correct or incorrect. And by assuming it as true for n equal to k, we can say it is true. We will assume it. That is only an assumption. Based on that one, if we are able to prove it as true for n equal to k plus 1, we can say the given statement is true for all positive, real, integral values of n, or in other words, for all n belongs to capital N, that is a natural number. N belongs to capital N, natural number set. Using this, in our first year 1A, we are having, particularly in algebra, we are having a very important chapter from which we can expect 7 marks question, that is mathematical induction. Now, mathematical induction. Now, in that, using this, I will discuss one problem now. Prove that Prove that 1 plus 2 plus 3 plus 4 plus 5 plus and so on n equal to n into n plus 1 by 2, where n belongs to n. This is the statement which we have to prove. 1 plus 2 plus 3 plus and so on n equal to n into n plus 1 by 2. That we have to prove. How to prove this one? First of all, let us write down Tn, that is nth term on the left hand side. First term is 1, second term is 2, third term is 3, fourth term is 4, fifth term is 5 and so on. Nth term is n. Tn equal to n. Let n equal to 1. LHS equal to 1. Substituting n equal to 1. RHS equal to 1 into 1 plus 1 by 2. 1 into 2 by 2. That is 1. LHS equal to RHS. Therefore, we can conclude that for n equal to 1, the given statement is true. The given statement is true. Statement is true. This is first part. Second part is, let it be true for n equal to k, k belongs to n. 1 plus 2 plus 3 plus and so on k equal to k into k plus 1 by 2. K is also a natural number. Given problem itself is named as first equation. This one is named as second equation. RTP required to prove. For n equal to k plus 1, it is to be proved. It is to be proved. Tk plus 1 equal to. Just substitute n equal to k plus 1 in nth term, that is tk plus 1 equal to k plus 1. Add tk plus 1 to equation 2 on both sides. 1 plus 2 plus 3 plus and so on k plus k plus 1 equal to k into k plus 1 by 2 plus k plus 1, because our present value of tk plus 1 is k plus 1, which I added. Take up k plus 1 common. K by 2 plus 1. K plus 1 into k plus 2 by 2. We don't know whether this is correct or not. For verification, put n equal to k plus 1 in RHS of equation 1. In the right hand side of this one, put n equal to k plus 1. K plus 1 into k plus 1 plus 1 by 2. K plus 1 into k plus 2 by 2. This value and previously simplified value both are one and same. Therefore, for n equal to k plus 1, it is proved as true. Finally, we will write down one statement. By the principle of mathematical induction, the given statement is true for all positive, real integral values of n. So, in this problem, we have taken nth term of left hand side. By substituting n equal to 1 in left hand side and in RHS also, we verified that both sides the values are equal. And after simplification of that one, we verified it and we assumed that the given statement is true for n equal to k, where k is a natural number. What is our requirement here for n equal to k plus 1? It is to be proved. Tk plus 1 equal to k plus 1. How did you obtain k plus 1? Here in nth term, in the place of n, we have substituted k plus 1. As all these numbers are connected by plus symbol, I have added tk plus 1 on left hand side. In between these two, k plus 1 common, k by 2 plus 1. K plus 1 into k plus 2 by 2. Put n equal to k plus 1 in right hand side. K plus 1 into k plus 2 by 2. This value and the value obtained after substitution both are one and same. Therefore, we can conclude that the given statement is true for all positive real integral values of n. In this procedure, we can work out any number of problems which were in our syllabus. As an example, let us take up another problem of the same model, that is, here you can note down, using mathematical induction, using mathematical induction, using mathematical induction, prove that a plus ar square plus ar cube plus and so on ar power n minus 1 equal to a into r power n minus 1 by r minus 1, where n belongs to n. N belongs to n. That is the requirement in this case. As usual, Tn is ar power n minus 1. Let n equal to 1. LHS equal to a into r power 1 minus 1, r power 0, that is a. RHS equal to a into r power 1 minus 1 by r minus 1, that is a. LHS equal to RHS implies for n equal to 1, the given statement is true. Given statement is true. That is our first part. Second part, let it be true. Let it be true for n equal to k. K belongs to n. In this case, what we have to do is, we will rewrite the given problem by replacing n with k on both sides. So, what will you get? A plus ar square plus ar cube plus and so on ar power k minus 1 equal to a into r power k minus 1 by r minus 1. RTP for n equal to k plus 1, it is to be proved as true. What does it mean? For n equal to k plus 1, we must prove it as true. Tk plus 1 equal to r power k plus 1, sorry, a into r power k plus 1 minus 1, a into r power k. Add tk plus 1 to equation 2 on both sides. A plus ar plus ar square and so on, ar power k minus 1 plus ar power k equal to a into r power k minus 1 by r minus 1 plus ar power k. Take LCM here. ar power k minus a plus ar power k into r minus 1 by r minus 1. ar power k minus a plus ar power k plus 1 minus ar power k by r minus 1. A common r power k plus 1 minus 1 by r minus 1. Put n equal to k plus 1 in RHS of equation 1. A into r power k plus 1 minus 1 by r minus 1. For n equal to k plus 1, it is proved as true. Proved as true. Therefore, by the principle of mathematical induction, the given statement is true for all positive real integral values of n. That's all. The same procedure can be adopted for all different problems, particularly in mathematical induction. Okay. Next, in the same pattern, another problem we shall work out. Prove that a plus d plus a plus 2d plus and so on a plus n minus 1 into d equal to n by 2 into 2a plus n minus 1 into d. Using mathematical induction. Using mathematical induction. Using mathematical induction. Here Tn equal to a plus n minus 1 into d. Let n equal to 1. LHS equal to a plus 1 minus 1 into d, a plus 0d, that is a. RHS equal to 1 by 2 into 2a plus 1 minus 1 into d. 1 by 2 into 2a, that is a. LHS equal to RHS. Therefore, for n equal to 1, it is true. That is our first part. Let us take up second part. Let it be true for n equal to k, k belongs to n. Rewrite the given problem by replacing n with k. a plus k minus 1 into d equal to k by 2 2a plus k minus 1 into d. RTP for n equal to k plus 1, it is to be proved as true. It is to be proved as true. So in this case tk plus 1. What is tk plus 1? A plus d, a plus 2d and so on, a plus k minus 1 into d plus a plus kd equal to k by 2 2a plus k minus 1 into d a plus kd. Take LCM, k into 2a plus k minus 1 into d plus 2a plus 2kd whole divided by 2. What will you have in between these two? 2a common. So, k plus 1 into 2a plus d into k minus 1 plus 2k by 2. Now what will you get? K plus 1 into 2a plus k plus 1 into d by 2. K plus 1 into 2k minus k plus 1 into 2a plus kd into k minus 1 plus 2 whole divided by 2. Then what will you get? K plus 1 into 2a plus kd into k plus 1 by 2. K plus 1 into 2a plus kd by 2. Put n equal to k plus 1 in RHS of equation 1. K plus 1 by 2, 2a plus k plus 1 minus 1 into d. K plus 1 by 2 into 2a plus kd. These two are one and same. Finally, we can conclude that, I will write down here, by the principle of mathematical induction, it is true for all positive, real, integral values of n. By which principle? By the principle of mathematical induction. With this, we will conclude today's session and I will give you one problem as homework. I will write down here, that is 1 square plus 2 square plus 3 square plus and so on n square equal to n into n plus 1 into 2n plus 1 by 6 using mathematical induction.